by heating until constant mass. What is the final mass of the solid? So it's telling me that I have 2.67 grams of this one, and I need to find the final mass of the solid. So if it's telling me solid, it's telling me to focus on this one, because this one's clearly gas. So I need to find the amount of mass of this one. And the first thing I'm going to need to do, step 1, is to find the molar ratio. How do I find the molar ratio? Just look at the coefficients. So it's telling me that this is 1 to 1. Okay, so I've identified that any mole of PB carbonate is going to be the same as lead oxide. So I need to find the moles of lead carbonate and equal it to the moles of lead oxide. How do we do that? Just as normal, we do grams over molar mass, 2.67. And just because I know IB so well, I bet you the molar mass is going to be 267, but let's have a look. Molar mass, if someone can put it in the chat, that'd also be helpful. Molar mass of lead carbonate. I bet you it's 267. It is 267. That's how predictable IB is, I'm telling you. 2.67 divided by 267 should give us 0.01 moles. And now that we have the moles, we can say, well, that's the same amount of moles as this one. So if I have the moles and I have the molar mass, I can find the grams. Now, what's the molar mass of lead oxide? Again, you would just look at your periodic table and you calculate the molar mass, lead oxide, molar mass. That should be 223.2. So you guys would get B. Did this make sense, everyone? Good job, guys. Thank you for the molar mass, by the way. Let me know how you feel about this question, if I can move on. 267. Thank you guys for putting all the molar masses. Yes? Okay, good. I'm going to move on. The next one is also a stoichiometry question. It says 0.02 moles of zinc is added to 10 centimeter cubed of 1 molar hydrochloric acid. How many moles of hydrogen are produced? This one's a bit different, but it's the same. Because it's still a mole question, but we've added a difficulty. We've added something called limiting and excess reagents. So the first step is you need to find which one's limiting and which one's excess. What exam board is this? Exactly, good for this is the IB. You need to find the limiting. Good job, guys. Is this a common question? Yes, the IB always starts, specifically for chemistry, they always start with a stoichiometry question. I would say 70% of the time it's always an Avogadro's constant question. But sometimes it's just like a mole question like this, find the grams and the molar mass. But it's a very, very common question. Exactly. So let's find the moles of HCl to see if it's limiting or if the zinc is limiting. How do I find the moles of HCl, guys? I do N equals CV, right? N is equal to the concentration, which is 1, times the volume, which is 10. Now, what do I have to be careful of? That it can't just leave it in 10 centimeter cubed. I have to put it in decimeters. So 10 divided by 1,000, that should give me 0.01 moles. And if my HCl is 0.01 moles and my zinc is 0.02, which one's the limiting? What do you have to be careful of, though, as well? Good, exactly. You have to be careful to apply the molar ratios. So here, the coefficient of HCl is 2. So before I can even pick, exactly, good job, before I can even pick which one is the limiting, I have to divide this by 2. So I'm going to do 0.01 divided by 2, and that's going to give me 0.005. And now I can see which one's smaller. It's as simple as that. Which one's smaller? Clearly my HCl is smaller. And the smaller one is going to decide how much I produce at the end. And they're asking me how much moles of hydrogen I produce at the end. Well, then because the HCl and the H2 are in a 2 to 1 ratio, that means I'm going to produce this one ratio of hydrogen gas, and therefore my answer is going to be A. Does this make sense, everyone? Thank you guys for 6K likes. I really, really appreciate it. So let me know if finding the limiting was easy, finding the moles after was easy, and getting the question. What time did live start? Literally 10 minutes ago. We're on the second question. Don't worry, you didn't miss much. Okay, good. I'm going to move on just because a lot of you guys are saying yes. And here we have an empirical formula question, also a very common IB question. It says 8.8 grams of an oxide of nitrogen contains 3.2 grams of oxygen. What is the empirical formula of the compound? So let's break it down before I give you guys a couple of seconds to think about it. It says N nitrogen oxide. So I know it's some sort of NO, and you can kind of look at the answer in the multiple choice and see, okay, I have to find the ratio of nitrogen to oxygen. And what do we do when we're trying to find the ratio of nitrogen to oxygen, specifically in empirical formula? The thing that's nice about empirical formulas is the steps are always the same. How many hours does the Bio HL SL crash course take? Good question. So basically the so the SL syllabus we do in 3 days, and we did it from like 9 to 7, I think. It's a full day, like just as if you went to school. But if you buy the recordings now, you can just put it on like 2 times speed or 1.5 times speed and watch it, I think, less in less time. So it depends how much time you actually sit in front of the computer and log in. You can definitely do it in half the amount of time we did it in because everything's just recording and you can watch it on 2 times speed. And that's for the SL. And then for the HL, it's like the last 2 days. So that's why it's total of 5 days. Okay, we need to find the mass of nitrogen by subtracting it. Good, I like that. So exactly, so if our total oxide, if our total oxide weighs 8.8, and it's telling me that the oxygen specifically weighs 3.2, then I can find the mass of nitrogen by subtracting it. So 8.8 minus 3.2 is going to be what? 5.6. Now that I have my grams, I need to find the moles. Exactly, good job. I find the moles. How do I find the moles? Just by dividing by the molar mass. What's the molar mass of oxygen? I'm going to say 16. What's the molar mass of nitrogen? I'm going to guess 24, 28. I'm trying to make an estimated IB guess. Molar mass of nitrogen. 28. Okay, close. 28. Okay, so that means here this is going to be roughly 3.2 divided by 16, which is going to give me 0.2. 5.6 divided by 28 is going to give me 0.2 as well. Okay, and then what do I do? Oh, it's 14, is it not? Sorry, guys, this is not 28. Ah, yeah, I did nitrogen gas. Apologies. You're right, you're right. 14, thank you. 5.6 divided by 14, 0.4. Okay, and then what do you do when you have both of the moles? It's always the same steps in the empirical formula. Ooh, someone calculated the hours. Thank you, Rosa. Rosa said that the crash course is 4.5 hours. I really like your videos. They're very helpful. I really like for you to post on YouTube. I'm going to try. I'm having a bit of trouble. Okay, divide by the smallest. Very good, guys. And which one's the smallest? Oxygen is the smallest. So I'm going to say 0.2 divided by 0.2, 0.2 divided, sorry, 0.4 divided by 0.2 gives me 2 to 1. So I know for every nitrogen, I have 2, and for every oxygen, I have 1. So what is the ratio? What's our answer going to be? B. Okay? 40.5 hours. Okay, 40 and a half hours, I think. Nice. Yay! Okay, moving on. You guys are doing very well. Naturally occurring gallium consists of isotopes. What is the approximate percentage abundance of 69 gallium? So hopefully you guys can see. I know it's a bit small. So this one says 71 and this one says 69. This is a very specific IB question that can show up. It's one of the 2 ways that IB can ask you about isotope questions. Are these past papers? Yes, they are. This is the HL May 2022 time zone 1. I'm going to put the discount code again for anyone that wants to join the crash course. So we talked about this on day 1 of the chemistry crash course. There's 2 ways they can ask you to do isotope questions. There's one way, which is much easier, and then there's this one, which is a tiny bit harder, but what's nice is that it's so repetitive. Yay, you remember. Okay, good. Do we log into your website and then put the code in for the video? So if you log into a website, then you purchase, you can put the discount code, and then you get access to all the videos and all the like resources, notes, and everything. What paper is this? This is May 2022, paper 1, HL time zone 1. Okay, I haven't started full revision for bio and chem, both HLs. There's still time to do the crash course? Yes, there's definitely lots of time. You can do the whole crash course in 5 days if you really want to cram it. I'm being so for real. Especially maybe even less, because you can watch on 2 times speed. Okay, come on, do it. Okay, I got it, Adam. Adam will do it for you. Okay, so for this one, for this isotope question, what do you do? Well, you know that both isotopes have to add up to 100%. Okay, so you're going to say let 71 be x percent and let 69 be 100 minus x percent because they both have to add up to 100. So then I just plug it into my normal isotope calculation question. 71 times x plus 69 times 100 minus x divided by 100 should give me this exact molar mass, which is 69.72. Not molar mass, sorry, atomic mass. And so then I can just rearrange this equation and solve for x. Let's see here. 69.72 times 100. Sorry guys, I'm going silent. I'm solving it. 71 minus 69. 2x is equal to, that should be 72. X is equal to 72 divided by 2. X is equal to 36. And so therefore 71 is 36%. And then to find the 69, I would just do 100 minus 36, and that should give you 64. So again, this is a non-calculator question according to the old syllabus. That's why they've said, what is the approximate? And so the correct answer here would be C. Okay? Just because it's a non-calculator question, and they know you would have to do this in your head. But in your new syllabus, you do have a calculator, so they definitely expect you to be specific. Does the paid program offer real-time help like any tutoring of any kind? Good question. So if you purchase before this weekend, you can still join the live crash courses. But I know a lot of you guys like still struggle with some questions because sometimes they like miss, or you just want extra help on a question. You can message the chatbot on the website and it gets you to a tutor, and then you wait like an hour and the tutor replies. We have like lots of students messaging the chatbot as well. So yes, you kind of do get real-time help. It's just a bit delayed because we have to receive your message, see it, and open it. And of course, you have access to all our emails. You can message us at any time and email us at any time. Okay. All right. Moving on to the next question. This is a very common question as well. But yeah, this is a common question, I would say, because a lot of teachers don't show students this graph, but it's so simple. Someone already answered it, and I'm proud of whoever already answered it. It says the graph shows the first 6 ionization energies of an element. In which group is this element? What are we thinking? What grade is this? This is IB chemistry. This would be in your year 1 content. Is this question HL? Yes, it is. Very good, guys. Some of you guys are putting the right answer. Nice. Exactly, good job. Someone even gave the reasoning. If this question is really easy for you, try to give the reasoning as well so you practice and do active recall. So someone said 13 because you have 3 valence electrons. Good, exactly. Whenever you see a big jump like this in your successive ionization energy graph, you're basically going from a shell to another shell. So if it's asking which group this element's in, you just count the number of dots before you see a big gap, because that gap represents that we've lost an electron shell. So here you have 1, 2, 3. So you know it's definitely going to be in group 13, because past this valence electron, this third valence electron, we've entered the next shell. Okay? Moving on, it says which gases are acidic, and this is going to be part of your new syllabus. We used to have acid rain in the old syllabus, but I think in the new syllabus they've highlighted it a bit more in terms of how you need to know like the specific equations and memorize them. So I predict something like this on your exam. If not on your paper 1A, then maybe your paper 1B or your paper 2. Are you going through only HL questions? I'm SL. So this is an HL paper, but some of the questions are doable by SL. So all the questions we've done so far should be answered by an SL student as well. All right, what are we thinking for this one? Someone said, I think all 3. So which gases are acidic? So we know 2 of them only cause acid rain, and that's the trick thing with IB. Okay, so you would only get the mark if this question said which one of these cause acid rain, and you would say nitrogen dioxide and sulfur dioxide, and we stress this in our syllabus. These are the only ones that cause acid rain. But this one is also acidic. So the fact that this question says which gases are acidic, you would say all of them, okay? But if this question said which one of these gases cause acid rain, you would have gotten the mark if you said 2 and 3. Sorry, 1 and 3. Apologies, guys. So the ones in yellow. Okay, so be very careful. How do you know? You just know those are this one, nitrogen oxide and sulfur dioxide, are the 2 ones that cause acid rain. Just memory, exactly. So does an accumulation of CO2 create acid rain? Good question. No. So acid rain is caused by the burning of fossil fuels, and they make that distinction in your syllabus. It's caused by the pollution of the air because of burning of fossil fuels, and these are the only ones. There's more, of course, but these are the ones in terms of your syllabus. This is a byproduct of combustion, of course, and it is acidic. How is CO2 acidic? Good question. So the fact that it's acidic is because it bonds to like hydrogen and forms an acidic gas. What we also know is, remember guys, you have to know your period 3 oxides. If anyone from the crash course can do some active recall and tell me when a alkali metal in period 3 becomes an oxide, is it basic or acidic? You have to know this. An alkali metal, basic or acidic? So careful, very good, exactly. Alkali metals are basic. And then you have one that's amphoteric. Does anyone remember that specific element that's amphoteric that you have to know? It's all in your period 3. It's a trick one. Very good. Aluminium, exactly. And then what do you know? You know your remainder of the period is all acidic. So this question is just referencing the periodicity unit. In terms of acid rain, you have to be able to distinguish that these are the only two ones that cause acid rain. So this is the correct answer because these are all acidic. How would you know that? It's just memorization of the periods. And you have to know that the metals are basic and then the non-metals are acidic. And then I'm just giving you a hint for the future. Whenever you see a question that says nitrogen dioxide and sulfur trioxide, know that that's referencing directly acid rain and it's not carbon dioxide because they bring that up a lot in past papers because they know teachers are not very good at distinguishing these two things. And so they trick a lot of students. Okay? All right. How do we feel so far? Does this make sense, everyone? This was also an SL question, by the way. Yes, okay, good. 7 says, which of the following is the electron configuration of a metallic element? Again, with the periodic table, it's going to be much easier to be able to see. But you don't have a periodic table here. Is this account going to be around next year? Yes, it is. Do you have flashcards for this topic? I think I do. Message me if I don't have them on the crash course, but I do have flashcards for the topic. I can put them on the crash course if you guys would like. So a metallic element, what are we thinking? What can we say? We can say, okay, let's just do process of elimination. We know P, anything in P is definitely not going to be a metallic element because that's a non-metal. Let's have a look at the remaining. This one's also in P, so it has to be C. Okay? Because this one, anything in the p orbital, we know the p orbital is on the right-hand side of the periodic table, and therefore we know that that's, of course, a non-metal. Everything that's here in the S block is a metal, and then we have the D block, of course, which is transition metal. So anything that ends with a P is going to be what? A non-metal, and that's how we know the answer is C. So that's a really good one to get on the exam as well. Okay, this was also an SL question, by the way. Let's move on to the next one. It says, why is hydrated copper sulfate blue? This one is an HL question. It's a transition metal HL question. So if you're SL, close your ears for a second. And if you can't answer this one, don't worry. We're going to cover the HL units this weekend in the crash course. Don't worry, we haven't covered this in the crash course yet. Okay, what are we thinking? So be very careful. What's absorbed is different to the one that's emitted. Can we use the periodic table that's on the No, you cannot. Careful. It's cheating. Okay, a lot of us are saying C. B. How much do I have to pay for the full chem crash course? By full, do you mean both SL and HL? If it's both SL and HL, it's 200. What does promoted mean? Good question. So basically, transition metals have colors because they have this specific D shell, which is so unique to them. And this D shell, what ends up happening is that you have the orbitals, because you have how many spots in your D orbital? You have 1, 2, 3, 4. You end up having 10 spots for electrons. And what ends up happening is that it splits into 5 and 5. And the reason why transition metals exhibit color is because electrons move. Okay, they move and get promoted between these d orbitals. Okay, yes, exactly. It has to be D. Perfect, guys. The answer is D. How do I know it's D? Well, because the light complement, if something is blue, then that's the light emitted. Okay, if something like is a color, that's emitted. And if the light blue is emitted, then we know automatically the one complementary to blue is absorbed. Because we know in our transition metal, the one that's emitted is the opposite of the one that's actually absorbed. Okay? So light complementary to blue is absorbed and electrons are promoted between the orbitals. Exactly. Let's have a look at the other ones. It's definitely not returned to lower d orbitals. It's definitely not returned to lower d orbitals. It's promoted. Keep that in mind. And so we would already cross out A and B. And then here is just trying to trick you with the colors. And you have to remember that it's the light complementary to blue that is absorbed, and therefore blue is emitted. What's the difference between C and D? Okay, so blue light is emitted when electrons are... Okay, so here just telling you that blue light is emitted, and that's not the case. Blue light is shown because the light complementary to blue is absorbed. Be careful with that difference. Okay, so what C is trying to tell you is that's basically saying that because the electrons are being promoted between these d orbitals, blue light is emitted, and that's not the case. It's because these electrons are being promoted between these d orbitals that light complementary to blue is absorbed, and therefore, as a result, blue light is emitted. Okay? What paper is this? This is the May 2022 Time Zone 1, paper 1H. This is an HL question. Yes, it is. Don't worry. If you don't know this is an HL question, we still haven't covered it in the crash course. We're going to get to it. Don't worry. Okay, next it says, compound consists of calcium 2 plus and phosphate 3 minus. What are the name and the formula of the compound? Again, we have a whole flashcard set for this if you're in the crash course. Hopefully you guys have been doing your revising. What unit is this? This would be stoichiometry. And this is both HL and SL. Okay, a lot of you guys are putting D. Yay, I'm so happy. Okay, you know that this is a phosphate ion, so you can already cross out A and B. And you know that because it's Ca2 plus and PO4 3 minus, they do a little crisscross like this. And so you know it has to be D. Good job, guys. So far, this paper has actually been really good. If I got this past paper, I would be so happy in the actual exam. Rate the difficulty of this past paper, guys. How are you feeling about this past paper? Okay, let's have a look at this one. It says, what is the explanation for the high melting point of sodium chloride? And we're going to do maybe just this last page and then move on to the paper 2 that you guys have been doing, that you guys have been requesting. This is May 2022 Time Zone 1, paper 1 HL. So sodium chloride has what? Ionic bonding. So I know it's definitely not covalent. I'm going to cross out A. Electrostatic attraction between sodium ions is strong. Okay, that sounds good. Intermolecular forces in sodium chloride ions are strong. All right, delocalized cause strong bonding in sodium chloride. Well, we know for a fact it's definitely not delocalized electrons. Is it B or C, guys? Is it intermolecular forces that cause the high melting point? Exactly, good job. It's B. It's the electrostatic attraction between those ions. And that's what's causing this to have a very high melting point. Good job, guys. For which species can resonance structures be shown? This is an only HL question. Have you done the 2024 Time Zone 2 yet? I think I have. So for this one, we just have to draw it out. And I'll show you how to do it. But yeah, exactly. You have to draw it out. What is resonance structure? So resonance structure is when you have a double bond that can occupy multiple different positions. The one with the double, okay, good. The one with the double bond, right? But which one of them has a double bond? So let's have a look at C. Let's try to eliminate the easy ones. C says CH3OH. Okay, that's just the CH3 with a hydroxyl group. It's definitely not C because there's not even a double bond. We're gonna move on. Let's try to do A. A is C double bond OH. How do I know that? Because it's a carboxyl group. Definitely not this one, because we do have a double bond, but this double bond cannot occupy multiple positions. Okay, let's have a look at B and D. I'm going to give you guys a couple of seconds. Okay, people are saying B. What are we thinking? How would you draw D, guys? B would be drawn out the same exact way we draw this one out, but without the H. So like this. Okay, and if it's drawn like this, what does that mean? It means that my double bond can be here, or it could hypothetically be here. We don't know. And that's exactly, it has two possible chances of having a double bond. And that's why my answer is B. Okay? Nice. Does this make sense why the answer is B, guys? Is this chemistry? Yes, it is. This is HL? Yes, this is an HL question. All right, moving on. It says, which compound are all carbon atom sp3 hybridized? This is also an HL question. So if your HL stay with us, if your SL stay with us, we're going to move on to another. Definitely D. What times do you do biology papers? It depends on demand. So before I start the live, I do like a little voting, I would say, and people will vote and I just do. So if you want to do a bio one, try to join in the beginning. I know it's hard to tell you to join in the beginning. But join in the beginning and vote and I'll do a bio one. It just depends on demand. What time do you usually go live every day? So the past few days I haven't been able to go live because I've been sick, but it's usually around this time, like after 6 p.m. How can you know without drawing the structures? Good question. I guess you could know just based on knowing like there's no, in this carboxyl group, there's no two double bonds, so you could cross that out. And you know this is a hydroxyl group, so you could also cross that out. But I think you'd have to draw it out. Is there a second course? No, but you can buy all of the recordings and watch them. And you can even watch them on 2 times speed, on 1.5 times speed, and watch it even faster than the people did it. It's 1 a.m. for me, but anything for IB Chem revision. You can still join. Don't worry, you can still join and watch the recordings. Or you can even join later, like join in the later topics according to your time. Okay, someone's saying B, 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 B. Okay, let's have a look. So sp3 hybridization. To do this, I'm going to draw them all out. I'm going to draw A. So A would look like this, I think. Like this. And so how many things is my carbon bonded to it? It's bonded to 2. Therefore, this is sp hybridization. So my answer is not A. Let's have a look at B. B looks like this. And that's how many things is bonded to the carbon, 1, 2, 3. And so therefore this is sp2 hybridized. Okay, let's have a look at the other ones. This one, my carbon would look like this. Sorry, that looks a bit weird. Like this, and it's bonded to 3 things, and therefore it's sp2 hybridized. And therefore that leaves my what? Leaves my answer to be D. Let's have a look at D if we draw it out. D would be drawn out like this. How many things is my carbon bonded to, guys? We can see that it's bonded to 1, 2, 3, 4, and therefore it's sp3 hybridized. That's why my answer is D. Okay, did that make sense? Is this HL or SL? This is an HL paper, and this is an HL question. But I'll let you know when the SL questions show up in case you want to do them as well. Okay. So it's only based on the central atom. Good question. So it's only based on the carbon atom. So if they tell you a different atom, focus on that atom. But here, it's telling you specifically focus on the carbon atom. Exactly. So it's just based on how many things it's bonded to. Exactly. So if it's bonded to 2 things, it's sp1. If it's bonded to 3 things, it's sp2. If it's bonded to 4 things, it's sp3. Isn't it just sp3 because of the single bond? No. Careful. No, that's not the case. Okay, I'm going to move on. But if you guys have any questions, I'm happy to go back. And this is the last question we'll do of this paper 1. And then we're going to move on to paper 2 because you guys were demanding. Not demanding, but you always want to do a paper 2. Okay, this is also, unfortunately, an HL question. It says, what are the electron domain and molecular geometries of the xenon fluoride molecule? Can you do an SL paper? I'm happy to do an SL paper. We just did a vote in the beginning and more people said they want an HL. So this one is an irregularity, and we talk about this in the crash course. You have to know this one by heart. You just have to memorize it, how to draw this one. Because IB mentioned that you do need to know this in the syllabus, and even if they didn't mention it, this is so common. Yeah, this is so common to show up on the exams. You just have to know how to draw this. How do you know if the carbon has a single or double bond? Good question. So the reason I know, for example, it has a triple bond here is because carbon's only bonded to 2 hydrogens. So therefore I know in order for my carbon to be fully satisfied, it must have 4 bonds. So then I make it share a bond with the other carbon. Exactly. Xenon for it specifically. You have to memorize just how it looks. Do you start these lives at 6? No, it really depends on the day. Do we need to know xenon? Exactly, you do. You do need to draw it specifically. So you do need to know it specifically, and you do need to know that it's drawn like this. It's one of the irregularities. Okay, that it has 4 main bonds and 2 lone pairs. Like you would not have been able to draw this. Like you just need to know. That's how it looks. It's a bit annoying, but you just need to know. So, what is the electron domain geometry? How many things is it bonded to, guys? It's bonded to 1, 2, 3, 4, 5, 6. So we know it's octahedral. And then is this giving a tetrahedral or a planar? What are we thinking? It's a. No, it's chill. Where can we check what we need to know, as you said? So you just need to read the syllabus and really need to read the syllabus, or you can have someone read the syllabus for you. So that's the perk of a crash course, is that someone reads the syllabus. Okay, a lot of people are saying tetrahedral. Careful, guys. This is not tetrahedral. Tetrahedral is bonded to 4 things, just like this, with no lone pairs. Can anyone recall what's the exactly? Very good. It's C. This is a square planar. They're a bit mean because they didn't mention square planar, but we know that that's called a square planar. Exactly, it's planar. Very good. Oh yeah, that's what I meant. I'd find the syllabus on the IB website. Yes, actually, they're not very nice about putting the syllabus on the website. You have to like dig. Just search up IB chemistry syllabus, and it's like I think it's like 100 pages. And if you find the one that's 100 pages, that's the one you should download. It's so hard to find. Yeah, it is. What I can do is I can find it now and put it in the chat if you would like. Why does xenon do bonds when it's a noble gas? Good question. That's why it's an irregularity. You have to know this one. Next one is SL. Yes. How do you have to memorize it? Why do you have to memorize it? Can't you just do it based on the valence electrons of xenon? No, you can't. Yes, please, the link. Okay, I can do it. Will you still do biology today? Okay, I'm gonna ask you now. Do you guys want to continue with this past paper or move on to paper 2, chemistry paper 2? And while you do that, I'm gonna go get water quickly because I'm really thirsty. You guys did want the syllabus link. Okay, wait, let me find the syllabus link. IB chemistry. Yes, please, Chem, continue with this. Paper 2. Continue. Okay, I'm seeing a lot of continues. I'm just gonna try to find the syllabus quickly. Yeah, I found it. Okay. How do I share this? Y'all, if you get a virus, this is not on me. Okay, put the link in the chat. Someone please open it and tell me if it works. Thank you. Does it work, guys? And we're almost at 10K likes. Yay. Thank you guys so much for all the likes. It doesn't work? Or it does work? Okay, let me send it again. Here. Did that work? You don't see it? Okay, wait. Wait. I know what to do. Guys, I got this. Give me a sec. How do I edit this? Can I edit this? No. Oh yeah, I can. Okay, try that. Can you join this link? This is weird. Oh no, you can't see it. Okay, wait. Give me a couple of seconds. I'm new to this, guys. I'm not used to this. Okay, can you take a screenshot of this and see if you can search it up on Google? This is the link. We can screenshot. Okay, yeah. This is the syllabus checklist. Someone do it quickly and tell me if it worked. No, just send it as a message. I've been trying, I swear. It's not showing. Okay, I'm gonna move on. Is this chemistry? Yes. Someone said you can also just search IB Chemistry Guide 2025. You can, but it doesn't always show up. That's the annoying part. Is the multiple choice going to be harder because you don't have a calculator? Yes, I believe so. Because you do have a calculator, yeah. Xenon has 8 valence electrons, so it shares 4 and has 2 bonded pairs. So why do we have to memorize it? I mean, sure. If you want to do it that way, you can. Because xenon is a noble gas, so you'd assume that you're supposed to assume that it cannot bond. That's why it wouldn't work. Are you a student taking the M25 exams? No, I already took the exams. I took the M23 exams. Okay. Sorry, guys. Did you say you wanted to do a paper 1 or move on to paper 2? Hopefully the link worked. Paper 2, paper 2, paper 2. Okay, I'm gonna do a paper 2. Oh. Do a few more paper 1. Okay, let me do a few more paper 1. I'm gonna move this syllabus thing now. Hopefully you guys took a screenshot. Take a quick screenshot. I'm gonna move it. All right, okay. Let's do this one and then move maybe in a second. Okay, have you ever redone your paper that you did in 2023? I have. It should be on YouTube. Okay, it says the energy from burning 0.25 grams of ethanol causes the temperature of 150 centimeter of water to rise by 10.5 degrees Celsius. What is the enthalpy of combustion of ethanol in kilojoule per mole? I'm going to zoom in so you guys can see here. What is YouTube called? Easy 7 IB. So does that mean whenever I text something in the chat, you guys don't see it? Or was it just a link? That's horrendous because I've been giving you guys discount codes. You don't see it? Oh God. Okay. Okay, I'm gonna put the link. The link should just be easy. The YouTube should just be Easy 7 IB Sciences. And then here's the discount code because apparently I've been putting in the chat and you guys haven't been able to see it, which is annoying. Here's the discount code for the crash course of Dion. Why did it get so big? All right. I usually see the code though. Maybe because it's a link. Okay, I think it's just a link. Okay. Okay, people are saying B, people are saying C, people saying A. Oh, people are giving different answers. Is chem and bio this year going to be crazy hard? I think bio might be. Chem, I don't think so. Chem is always hard. Okay, people are saying B, it's A. Let's have a look. So, we know with these combustion questions, the first thing you must always remember is never, ever, ever, please, never convert to Kelvin, guys, I beg you. So you can cross out C and D automatically, always. 1000%, I'm telling you from the bottom of my heart, never. Okay, so you're already 50% chance of answering this correct. Next, you need to find the enthalpy of combustion. So what are you going to do? You need to do delta H is equal to Q divided by N. Okay, once we've done that, we need to find Q and we need to find N. How do we find N? Simple, grams over molar mass. So 0.25 grams, 0 grams divided by the molar mass, which they've given you here is 46.08. Okay, I found the moles. How do I find Q? MC delta T. M is 150. Specific heat capacity is 4.18. Temperature is 10.5. Now, what do you have to be careful of, guys? No, clock yourself. Whoever says A, clock yourself. Correct yourself. What unit is Q in always? Honey, can we be besties? Of course. Why not convert into Kelvin? Good question. You never convert into Kelvin because your Q equals MC delta T is in delta T, in change in temperature. Okay, so if it's in change in temperature, there's no unit for changing in temperature. Like if you increase 1 degree Kelvin, that's the same thing as increasing that amount in Celsius. It's just change. Okay, so be careful. You never convert to Kelvin. And here, your Q is always going to be in joules. Just that's the way the formula is. Your formula is always going to be in joules. So whenever you're converting it to delta H, you must remember to divide by 1000. And that's why my answer is B. Okay? Do we use degrees just for this equation? Yes, exactly. Only this equation in the IB syllabus, you must use degrees Celsius. You need to go from joules to kilojoules. Perfect, exactly, because we know that enthalpy change is kilojoules, and we know that Q is always going to be in joules. But if it's in kelvins, you convert it to Celsius. Good question. No, you keep it in the unit they've given you, but they always do Celsius. Is this for bio? No, it's chemistry. We can use Kelvin too, though. You can, I wouldn't. Because then like you just lose a no, just keep it in Celsius. Keep it in the unit they give it to you, and I'm gonna say 90%, 95% of the chance it's gonna be Celsius always. Okay. Exactly. If you get it in Kelvin, you keep it in Kelvin. Exactly. When doing delta T doesn't matter, cancel out. Perfect, guys. Let's have a look at this one. It says, what is the enthalpy change of the following reaction? And this is only a HL question, just because it's a enthalpy of formation. You could do this as a student just knowing Hess's law. Okay. But you would not get this on the SL exam. Is this not exothermic? Good question. So it's the enthalpy of combustion. Good job. It is exothermic. So this would actually have to be negative. You're right. How did you guys do this without the calculator? Girl, it was hard. I don't know. Nice. Someone said the answer, product minus reactants. Exactly. It's always product minus reactants when we're looking at formation. Simple. So if this is my product, then this is going to be my product. And then this is going to be my reactant. This is my reactant. So what do? You do negative 156.0 minus 0.1 plus negative 3.63. Okay, that's going to give me negative 156 minus negative 36.2. And then that's going to be the same thing as plus. So 156 plus, no, minus 36.2 is going to give me, damn, I did something wrong. What did I do wrong? Let me do this on the calculator. I was trying to be cool. 156 minus. Yay, okay, that should give you negative 11.8. This one, C. Did you guys also get C? Yay! Kavya got it right. Good job, guys. Good job. I don't know how to say your names, but good job. What if it's combustion? Good question. If it's combustion, it's the exact opposite. Reactants minus products. It was that easy, yeah. He's always going to say the formation or combustion. Yes, 100% of the time, except if they ask you a different type of enthalpy question. So they could ask you Hess's law question, and they just tell you that that's the enthalpy per mole, but then that would be a different way to solve it. Like you have to do the triangle, or you have to do the one where you flip on the equation and multiply by the coefficient. Okay, moving on. Which compound has the largest value of lattice enthalpy? This one is also HL. What are we thinking for this one? It's all about the what. Can they force you to do the triangle thing, or can I always flip? Good question. I hated the triangle thing. I only learned fully the triangle thing when I got into uni, and I got away with it. So I think you can get away with it. Largest charge, smallest radius. Yay, good job. So which one is the smallest radius? Charge and size, exactly. So we know it's definitely going to be sodium. It's not going to be potassium. And then which one has the smallest size? Is it going to be oxygen or sulfur? Can you do this question step by step? Because I don't understand it. Do you mean this one or the previous one? So A, good job, exactly. Oh, exactly, good job, guys. That's why my answer is this one. Okay, so the largest lattice enthalpy value is just dependent on something that has a small radius and large charge. So whenever you have something that has a small radius and large charge, What do I mean by large charge? I mean, like, rather than having a +2 being a +2 cation, it's a +1 cation, it's a +2 cation. Okay, so the larger the number of the charge, the more electrons it loses, the smaller the radius it is, and therefore the larger energy it releases in terms of Lutz enthalpy. Okay, this is an HL question. Moving on. This is also an HL question. It says, in which reaction does entropy decrease? How do you know about the radius part? You just look, because sodium has a smaller radius. Because remember in the periodicity unit, you learn like that down a group, the radius increases, across a period, the radius decreases. So you just look that down a group, that potassium has a larger radius. Does that make sense? Please let me know if that makes sense. Oh, yeah, okay, good. Good job. Good job, Isabel. She said a less ordered state to a more ordered state. Good job. So a decrease would be a gas to solid. Good job. Exactly. Very nice. So here we see a more ordered state. So solid to aqueous. So it's definitely not A. Here we see solid to aqueous and gas again. Definitely not B. Here we see gas to solid. That's more like it. So that my answer is going to be C. Let's have a look here. It says solid to gas. That's therefore my answer is not going to be D. Does this make sense? Yay. Okay, good. Let's have a look at this one. This is a really good question. If you guys get this, I'm gonna, I don't know, I'm gonna celebrate. But this is a really, really good question to get on the exam. And they always, I think every other year, they pull up a question like this. So please read this carefully. And if you guys get this, I'm gonna be so, so proud. How do you revise? I would recommend joining the crash course. This is a good question. This is a SL question as well, but it would be a really, really hard SL question. Zoom out, of course. 17, the answer is C. I'm going to give you guys a couple of seconds to do this. Eggshells again. Someone's from the crash course. Okay, I'm going to give people a couple seconds because this is a hard one. Okay, I have an A and I have a B. You did this 2 days ago. How did I forget? Don't worry, it comes back. You just do a bunch of practice. What is the crash course? So the crash course is a course that we do in 5 days where we teach the whole syllabus. In SL, if you're SL, we do it in 3 days. And if you're HL, we do it in 5 days. And you learn every single thing in the syllabus. You get notes, you get a resource pack, you get practice questions. Okay, I'm getting B's, A's, C's. Okay, I'm gonna answer it. Definitely B. All right. Okay, I'm gonna answer it now. It says a sample of calcium carbonate reacts with excess hydrochloric acid. Key word whenever you're looking at these questions is look at what is in excess and what is limiting. So I'm gonna circle in big that my excess is hydrochloric acid. The solid line shows the mass of the beaker changes with time. Which dashed line represents the results obtained when the acid concentration is doubled? So if this acid is in excess, will it affect the amount of product formed or will it not? So you say yes or no if it will affect. Will it affect? No. Good, exactly. And that's the key trick that IB love bringing up over and over and over and over again. It will not affect. So what can you cross out? You can already cross out C and D. Nonetheless, if a concentration is doubled, we know concentration increases rate of reaction. So my answer is going to be B. So if you said B, good job. This is a really, really hard question. Why wouldn't it affect? Good question. It's because it's in excess. Remember, the only thing that affects the amount of product formation is the limiting. So if I change, okay, have a look at this. If I say calcium carbonate plus HCl forms calcium fluoride plus H2O and CO2, and I asked you to find how many moles of CO2 are produced, what would you do? You would find the limiting, and then you would find the molar ratio between CO2, and then you would say how much CO2 is produced. That's only in the case with the limiting. Here, this is a really, really good question for IB to bring up because they're mixing stoichiometry and kinetics. And they're playing on the fact that a lot of students are just going to read over this and jump to conclusions. We have to remember that if something is in excess, it doesn't matter. That's not what's going to affect the amount of mole produced. It's going to affect the rate of reaction, okay? But it's not going to impact the amount formed. Why is B lower though? Good question. So this is lower because you're looking at the mass change of the beaker over time. So what are you doing in this reaction? You're taking hydrochloric acid, you're taking calcium carbonate, and you're measuring how fast the mass of the calcium carbonate uh like leaves, decreases, goes away. How much it forms CO2. Because we know when you're looking at a change in mass, you're basically looking at CO2, how fast CO2 is being formed. Okay? So you're basically seeing that it's being formed much faster, CO2. And the way it's so clear is because the mass is decreasing. Okay? Because excess isn't reacting with anything, right? Which is why it doesn't affect. So it does react, good question, but it's not the thing that's going to affect how much moles I produce. This is HL, right? No, this is an SL question. Yeah, someone said the axes are flipped, so if I'm looking at it upside down because concentration makes it faster. I guess you could look at this upside down. Do you guys want me to re-explain? Tell me in the chat if you want me to re-explain, because this is a really common question to show up, and it always distinguishes the higher marking students. Okay, re-explain. Okay, so I'm gonna break it down step by step. Here I have calcium carbonate reacting with HCl. I'm going to ask you a simple stoichiometry question. In a simple stoichiometry question, is it my limiting or my excess that affects how much gas produced? Like how much product is produced? My limiting or my excess? Limiting. Okay, we got that. So I know that this is my limiting. So only the amount of this, the molar ratio of this, is going to affect how much CO2 I produce. Okay, remember that. Here I have in my closed environment HCl reacting with, HCl reacting with particles of calcium carbonate. Now, why are we measuring the mass changed? Because you always measure in kinetic questions the mass lost when you have gas formation. So if IB asks you, can I measure the mass lost in this equation, and you see in the products that there's gas formation, you say yes, because that means that the mass is decreasing because we see that the gas is evaporating. So here in this question, we know calcium carbonate, HCl, produce gas, okay? Just so you guys understand why my mass is decreasing like this. But bringing it back to the question, we know that the limiting is what affects how much product I produce, okay? How much of this actually goes down, how much of this mass decreases and goes into forming the CO2 gas. So if I tell you that I double the excess acid, that means it doesn't matter how much the excess acid does not affect how much moles of product I produce. It's all dependent on the limiting. It doesn't matter that I double the concentration because only when I change the limiting does that affect my product formation and therefore affect my mass loss. So we can say because this is excess acid and we're doubling the excess acid, it cannot double the mass lost. So it can't be C or D. Okay, but we do know, however, that whenever you just double concentration, back to the kinematics unit, that increases the rate of reaction, and that's why I'm losing mass much faster, and it has to be B. Does this make sense, everyone? Exactly. If the limiting reactant were to double, that would be the correct line. Exactly. Does this make sense? Yay! Oh, thank you for the gift, guys. You guys have been sending me gifts. I haven't even been realizing. Thank you guys so much for the gifts. I really appreciate it. And we're at 13K likes. What days do you guys have lives? I try to do it every day. I've been sick. That's why I haven't been able to do it. Hopefully I'll go again tomorrow. Okay, nice. I just want to remind everyone this is a discount code for our crash course if you really want to join. I do teach most of the crash course with my co-lead tutor, so if you're really liking this teaching and want to learn the whole syllabus in 5 days, I really recommend you guys join our crash course. Okay, moving on to the next question. What exam board is this? This is IB. What time do you go live? It's usually after 6 p.m. You do medicine? Yes, I do. If I got a low 5 in my biomock, do you think I can redeem myself? 100%. Where do I sign up? Oh my God, our website. Do you do bio? Yes, we do. How can I contact you? You can just DM us on TikTok, or you can even DM the chat bot on the website. Okay, we're going to move on to the next question. It says a student investigating rates of reaction. Which of the following cases would a colorimeter show a change in absorbance? This is let's see. This is an HL question. I was trying to see which one the answer is. This is an HL question. I guess you can answer this if you're SL, but no, I would say this is an HL question. Okay, I think D. All right. What is making you think D? Careful. It's either A or D. Okay, A. Nice. B, D. Thank you for the gift, Evie. Thank you so much. Someone said the answer. Someone said, this is a trick question because tertiary alcohols can't be oxidized. Good job, exactly. That's why I was trying to see if it was an SL or HL paper, because you could have answered this based on that. And yes, that is true. So we know that D can't be the answer because this is a tertiary alcohol, and therefore you will not see a color change. Exactly. So it can't be this one. Do acid-base reactions have color changes? No, we know that acids and bases are usually colorless, and you have to know that for your exam. But we can know that you can add an indicator and that can show us the equivalence point. But that can't show a color change. Exactly, only the indicator. Very good. Next, it says copper and sodium. Now, this is a bit of a difficult one, but can you guys tell me which one's more reactive? Can this displacement reaction actually occur? Is copper more reactive than sodium? Sodium, exactly. Sodium is much more reactive. And a little trick I like remembering is please stop calling me a careless zebra and start learning how copper saved gold. And it's basically like potassium, sodium, please stop calling it calcium. It's like it shows you all the list of reactivity in order of the metals. So I would recommend you guys remember this mnemonic. And we know that sodium is not more reactive, so therefore this reaction does not even happen. And therefore it has to be this. And yes, we do know that chlorine is more reactive. It's higher up in the group, and therefore it displaces bromine, and that's why we see a color change. Okay? The reactivity series, I think it's also in the formula booklet. Exactly, yes, it is in the formula booklet. For this question, we did not have the formula booklet in our exam, that's why. If I mix Coke and Mentos, can you say the mnemonic again? Yes. Please stop calling me a careless zebra and start learning. If you search it up, you're gonna get it. How copper saved gold. And then if you search it up, it's gonna tell you that this is like potassium, this is sodium, calcium, so on. Magnesium. What was your way of remembering that? This was the way. But aren't only transition metals colored? Good question. So remember halogens, you have to know that they're colored, and you have to know the colors specifically. And here, this reaction doesn't even occur. Okay, because copper is not strong enough to displace sodium. If it was, then this could have showed a color change because we know transition metals are colored. What year is this exam? Good question. It's just the May 2022 time zone 1 HL paper 1. Hi. Again, guys, here's the discount code for our crash courses if you guys want to cram the syllabus with us in 5 days. This is, I think this would be a really hard SL question, but I would see this more in an HL exam just because in SL you don't even know what a colorimeter is, and then yeah, it would be a hard SL question, but you could answer this if you're SL. How much do you have to pay? So our crash courses are 205 if you're both HL and SL. If you're only SL, it's 130. And you get all the content, all the resources, and you learn everything. Chlorine is green. Chlorine is yellow, exactly. How much is private tutoring per session? It depends on on the tutor you want. Okay, do you have any tips for memorizing? I would really recommend flashcards. I mean, for some of our crash course units, some of our students have asked for flashcards and I've made them for them. Okay, so just use flashcards and use a whiteboard. Okay, let's have a look at this question. This is a HL only question. The table shows data for the hydrolysis of halogen alkane. Which statements are correct? And this is a really hard one. And if you can't answer this and you're in the crash course, don't worry, we haven't covered this. We're going to cover this unit this weekend. So don't even worry about it. Thank you for the presents, guys, and thank you for 16K. Someone said D. Okay. I'm going to give you guys a couple of seconds. Yes, exactly. So chlorine is yellow, bromine is brown, and then iodine is purple. Remember that. How much is it if I want you as my tutor? Unfortunately, I'm not taking any students right now just because I'm so busy with the crash course. But when the crash course is over, I can tutor you. I think D2. Okay, nice. Is anyone thinking something else, or should we answer? This is HL. Yes, this is an HL question. C. Okay, let's have a look. So it says the reaction is first order in terms of RCl. Okay, let's have a look. So if it's first order, that means that it's directly impacted. Let's see. When I double the NaOH concentration, what happens to this one? Can anyone tell me? Does it double? The crash course is taught by me and my co-lead tutor Minna. My name is Haneen. Do you recommend MSJ Chem? Bro, I love MSJ Chem. I love MSJ Chem. What an icon. I think I bought him 10 coffees. Doubles. Okay, good. Exactly, it doubles. Okay, so when this doubles, this also doubles. Now let's have a look at in respect to RCl. So when this doubles and this stays the same, what happens here? It roughly doubles as well. So we know, yes, the reaction is first order because when this one doubles, this one doubles. And we can say that the reaction is second order overall because this one is first order and this one is first order. So in combination, they are second order together. And then it says the reaction proceeds by SN2 mechanism. Can anyone tell me if it's SN2? How do I know it's SN2? How do we know? Are you Egyptian? Yes, I am. What is meant by first order? So, in simple terms, in the most simple terms, first order basically means that when I double this concentration, what ends up happening to the rate? And it's the ratio is 1 to 1. And the reason I say that is because when I double this one, the rate also doubles. So the ratio is 1 to 1. That's how we know it's first order. If it was second order, it would be when this one doubles, the other one quadruples. So the ratio would be 1 to 2. We do know that this reaction does proceed by SN2, right, guys? That's why my answer is going to be D. What topic is this question? So this would be organic, and then the rest of this question would be kinetics. I'm so confused at the mechanisms. Don't worry. We're going to cover this in the crash course. Okay? Does this make sense, everyone? Thank you guys for 17K. What's the difference between SN1 and SN2? That's a big one to explain on the live. Is it because it's primary? Exactly. Good job, Evie. Damn, Evie's slaying. And she's sending gifts. So SN2 mechanisms, remember? Remember SN2 and SN1 mechanisms are organic chemistry mechanisms in which a reaction proceeds, and it all depends if my halogenal alkane is primary, secondary, or tertiary. How do we know if it's primary if it just says, okay, good question, Gigi, very good question. So when something is RCl, this R represents a carbon group. Oh, you can't see that, sorry. If something is like RCl R prime, that represents that it's secondary because there's two R's. If something has that again in a third one, that means it's tertiary. So it tells you it's primary. Okay? Does that make sense? Yeah, okay, good. Let's have a look at this one. It says, what is the activation energy according to the following plot of the linear form of the Arrhenius equation? And I know a lot of you guys, well, a lot of my students did this for their IA. So if you guys have done this for your IA, you get an advantage because it's part of the syllabus, but it's a very rude question of IB to ask because it's more math than it is chemistry. SN1 and SN2 mechanisms are HL, yes. Bro, my teacher had 2 years and didn't even finish the syllabus, and you're doing it in 5 days so well. Thank you so much. That's very kind. I want to know your name. It just says P. It's really annoying me. Is it combined science? No, this is chemistry. Again, guys, if you're new and you've just joined, we do offer crash courses where we teach the syllabus in 5 days. And here's a discount code that you guys can use if you want to join. Yasmin. Okay, perfect. I'm going to remember that, Yasmin. Couldn't even guess that you're Egyptian from that accent. Oh, that's offensive. You just have to know. Yeah, exactly. You just have to know. I don't know what she's responding to, but you just have to know. Okay, is anyone? Oh, yay. Hi, Nicole. She's also Egyptian. Good. Someone already put the gradient. Nice. Exactly. And how did you do that? Did you just memorize the gradient or did you do some math? Because for this one, they want you to do some math because it's actually not part of the syllabus for you to know the gradient. I mean, we have it in the crash course because we know the IB, but it's not in the syllabus. And also, yeah, we're all Egyptians here. Mom's gonna go insane. Okay, let's have a look at this. So, how do we find the gradient? Well, we know to find the gradient, we need to, exactly, very good. Someone said it, take the ln of both sides. So I'm gonna take the ln k of this side and take the ln a of this side. And then ln k is equal to ln a plus ln e negative ERT. Okay, and since we're doing, sorry, I did that wrong. Negative ERT like that. Since we know our y value is this, and our x value is this, well, we can say that this is my y value, and this is my x value here. So if we rearrange that, we can have ln k equals ln a plus ln e negative e over r 1 over t. And what does that show us, guys? It shows us that this is our y value. This is our mx value, because we know that this is our x value, this is our y value. So therefore, and this is our b, you can rearrange this equation and write it in y equals mx plus b. And then you have m, which is your gradient, we know that from math, to be what? Negative. Can anyone tell me? Is this HL? Yes, it is. Don't worry. This is where I quit. Yeah, I know. Me too, Yasmin. Exactly. So we know it's negative 2, the gas constant, which is 8.32, divided by 0.06. Okay? That's why my answer is B. It's just a bunch of math. This is really rude for the IB to put. I would expect like 30% of students to get this, unless they've done this as their IA, which is really unfair, because it's a disadvantage. But basically, if you don't get this, is that you're trying to make this equation in the format of y equals mx plus b, and the way you do that is by taking the ln of both sides. Why isn't the gradient negative e? It is, you're right. The gradient is negative ER. Nicole, it is, you're right. Someone asked a question, but it's not chem related. Tell me. Okay, let's have a look at this one. Because we've been going at this for long. It's been an hour. I know, it's not chem... Exactly. Sorry, I just got your question. So you're saying it's not chem related at all? It is not. It's math. That's why I was saying in the beginning of the question. It's really a math question. It's horrible for them to do this. Can you zoom out a little? Of course. This is a HL question. Yay, we hit 20K likes. Thank you guys so much. We're almost done. We're like halfway. I think I'm gonna do another page and then end the live. But I really hope it was helpful for you guys. Okay, what are we thinking for 22? Thank you, Evie, for the gift. Okay, so let's have a look at this. It says we reverse the equation because this was in the products and now it's in the reactants. So I know when I reverse something, I do 1 over Kc. And then I've also multiplied this by how much? By 2. Okay, so if I've multiplied Kc by 2, it means I have to square the Kc value. So my answer has to be D. If you got D, that's correct. It's not times 2, careful. When you multiply the equation, you square the Kc value. Nice, exactly. Okay, it says at equilibrium, the concentration of chlorine and iodine are both 0.02. What is the concentration of iodine monochloride? This is also a nice question. I think the past questions have been easy except that graph one, which is hard. This is no, this is no, this is SL. You should know this if you're SL. What year is this paper? Good question. It's the May 2022. 2022 time zone 1 HL. Okay, what are we thinking? Jamie says D. All right, careful, Jamie. Yasmin says B. Gigi says D. Can you please do database questions? I can. Maybe next live? I can go live again tomorrow if you guys would like. C? Okay, let's have a look. We know Kc is equal to products over reactants. And you have to take into account the coefficients. So ICl over I2. Oops, sorry guys. I2 to the 1/2. Cl2 to the 1/2. And therefore, I just have to plug in my values. My Kc value is 454. My iodine and chlorine are both 0.02 to the 1/2, 0.02 to the 1/2, and therefore I have to solve for this ICl. Let me rearrange my equation. 454 is equal to ICl, and then 0.02 times 0.02 times to the 1/2 times 0.02 times to the 1/2 is going to be 0.02. So my final answer is 454 times 0.02, and that should give you your ICl value. I think Jamie did get it right. Did I call? I think I called Jamie out and she got it right. I'm sorry, Jamie. I don't remember what Jamie said, but good job, Jamie. It was B. Yay, B, exactly. Oh my god, completely missed the 1/2 step. That's okay. Now you won't miss it. Have you been posting on YouTube lately? No, because I've been having an issue with downloading the video from. No, you said D. Okay, it's fine. I've been having an issue downloading the video from TikTok Studios, but I'm gonna work on it now. Okay, I'm gonna work on it like for 30 minutes after the session and try to upload all the ones. What do you post on YouTube? So a lot of people can't join the lives in real life because of different timings. So I try to post the live again on YouTube. Okay, which species are acids in the equilibrium below? So if something is acid, what are we gonna look at? I'm gonna give you guys a hint. You should be able to answer this. I'm not kidding, in 20 seconds. So I'm gonna count. Very good. Judy said it. Okay, I gave you guys, I think, 20 seconds. So hopefully this was a quick one to answer. Basically, you know you have acid-base pair. And always your acid-base pair, your acid is always going to be the one with more hydrogen. So here's my acid-base pair. Which one has more hydrogen? This one. So I know it's going to be that one. Here's my acid-base pair. Which one has more hydrogen? This one. So I know my answer is going to be this, and it should be B, and you should move on. That's how fast you should be answering this one. Okay? Did this make sense, everyone? Hopefully it did, because this would be a really good question to get on the exam. Yay! Okay, good. It says which 0.01 molar aqueous solution has the highest pH? This is also a good one to get. Damn, this is a really easy past paper. May 2022 times on 1 for anyone who's asking. Good. Aren't acid proton donors? Exactly. That's why they must have the extra H's so they can donate them. So if you ever have an acid-base pair, just look at the one that has more H's, and that's the acid. Okay, people are saying C. So highest pH means that it's basic. So what can we say? We can say it's definitely not HCl. It's definitely not H2SO4. So it has to be between NaOH and NH3, and we know that this is weak, so therefore it has to be C. Okay, this is a really good question to get. Moving on, it says which statements explain the Lewis acid-base nature of chloride ion in this reaction? And this is a HL only. Do you think the chem papers will be hard this year? I think the chem papers are usually hard in general. And I think the chem old syllabus is practically the same as the new syllabus, apart from like a couple new environmental things, which I think make it a tiny bit harder. But I think the chem will be on average the same difficulty as the old ones. I think the bio one, it's either going to happen two ways. Either the bio syllabus, the bio past paper is going to be so easy because they feel so bad that the bio syllabus is horrendous, or it's going to be so hard because the bio syllabus is horrendous. But chemistry is kind of the same as the old one, so I think it's going to be the same. Okay. ISP, this year's IB exam will be extra difficult due to COVID recovery happening fully. Any tips on? Okay, someone said, is it A? Are you a teacher or a student? I'm a uni student, but I teach. Well, I remember the violin charts in bio. That was traumatic. Can't believe SP still remembers that. Is there high school? This is IB chemistry. Is IB harder than A levels? I think so. Okay, someone said Lewis base is a nucleophile. Thanks, SP. Bye-bye. Is it okay? We're gonna make the grade boundaries for him. Go look. Yeah, exactly. Yes, whoever made the bio syllabus is horrid. I agree. Okay, Lewis bases donate a pair of electrons. Okay, nice. And where do we see what donates what? If something is positive, what do we know it does? Like if let's think of Mg2 plus. If it's a cation, what does it do? It loses electrons, or it wants to lose those electrons. If something is negative, what does it do? It accepts electrons. Okay? You can think of it like that. Exactly, gains or exactly, nice. So we can think of it like this. And does a Lewis base donate or accept a pair of electrons? What are we thinking, guys? Donates, exactly, very good. The way I like to think of it is that bronze lauric acid donates a proton. So this time the base donates, if that helps you guys. So it does donate a pair of electrons. Okay, so what can we do? We can already cross out this one, and we can already cross out this one. And in this case, is my chloride ion a base or an acid? Is it donating or accepting? This is an HL question. It's a base, right? Because it donates the pair. Okay. So like we switch exactly. So we switch the lowest acid base for bronze lauric. Exactly. So Lewis bases accept, but bronze lauric donates. Exactly, yes. Don't bases accept. No, it should donate. How can you remember everything for bio? I really recommend flashcards. Okay, let's have a look at the next one. It says, in which set are the salts arranged in order of increasing pH? Exactly. Someone said that Thank you, Yusuf. Yusuf said, Bronsted Lori base accepts, Lewis base donates. That's how you remember. I always remembered it like that, remembering the opposite. Evie suggests that you blurt. Blurting the long process is helpful. Yes, I recommend flashcards. I recommend you read mark schemes and like learn from mark schemes. Like for example, if you're trying to learn the Krebs cycle, for example, rather than watch a video, watch the crash course, watch whatever to learn it, but rather than like memorizing your whole Krebs cycle, find a past paper that has that, and then memorize the first step and have that be your first step that you're memorizing, because then in your exam you know exactly the steps you need to write for that mark and you're not memorizing anything like stupid, if that makes sense. Okay, all right, let's have a look at 27. We're going to do 27 and 28 and end it for today. But it says which one is an order of increasing pH, so we just have to look at which one's more basic. What are you guys thinking for this one? So here I have, let's have a look. So here I'm getting ethanoic acid here with ammonia. Okay, how do I know that? I'm just splitting up the acid and the base. Okay. What about here? Here I have potassium hydroxide and HBr, which are both very, very strong. So this should be roughly around 7. Here I have a really strong acid, which is HBr, and I have a really weak base, which is NH3 or NH4. And here I have a weak acid, which is ethanoic acid and potassium hydroxide. From that, you should be able to know that, okay, potassium hydroxide, the weak acid and strong base is going to have the highest pH because the strong base overpowers. So I'm going to cross out B and D. And then let's have a look. Here we have HBr and potassium hydroxide. Okay, so then the lowest one is going to be the one where your acid is the strongest and your base is the weakest. Does this make sense, everyone? The fact that this is a strong base and this is a weak acid and therefore it's the highest, and this is the strongest acid and this is the weakest base and that's why it's the lowest. How do you know it's HBr and potassium hydroxide? You just know that the only acid that can be formed with bromine is HBr. Do you guys want me to show you a little trick that I teach my students on how to remember acids and bases? What are the strong bases again? Okay, rather than doing the last question, I'm going to show you this trick and then we're going to finish for today. I'm going to show you how to remember. Okay, so this is your periodic table. It's a bit ugly, but this is your periodic table and it's lopsided, but that's okay. So everything that's here, all your alkali metals here, form strong bases. Okay, just remember that. That's going to be a strong base. So if you see anything that does not include this, like ammonia, that's weak. Any other base you see that's not including any of these metals is weak. Okay, weak base. Sodium hydroxide, potassium hydroxide, magnesium hydroxide, all of these are going to be strong. Now, what about acids? Anything that is formed from the halogens is going to be very, very strong acid. Anything that's H2SO4, HNO3, H2NO4. Wait, I forgot. There's 2 nitrate ones. But any of the nitrate ones, any of the sulfur ones, and any of the halogens are all your strong acids. Otherwise, everything else will be a weak acid. And that's all you have to know for your exam. Okay? So quick trick. You need to memorize them, exactly. But quick trick, anything that's alkali, you need to know for your exam is strong. Anything else that you see as a base, then you know, of course, it's going to be weak. If it's not a halogen, if it's not this triple combo of acids, then it has to be a weak acid. Okay? And you can like confidently assume that. And generally things with like ethanoic acid are very weak, like the Cu groups.